Okay, for question 17, we've been told that a biased six-sided dice is thrown a total of 1,000 times. The graph shows the relative frequency of throwing a 6 after 200, 4, 6, 800 and 1,000 throws. So this is a biased dice, so we're not going to get the results we should expect from throwing a fair dice. So looking at the relative frequency on this axis, and this is the number of throws on this axis, we see our results plotted on this graph. So the first question asks, which of the following is the best estimate for the probability of throwing a 6 with this dice? Circle your answer. So whenever on relative frequency problems they ask that question, you look at the result based on the greatest number of throws. So in this case, we've got a number of throws of 1,000, and we have an answer of 0.32. And just be careful just to check what the increments are on the scale. What are we going up in? What is each step worth? So for that first answer there, we are looking at 0.32. For part B, part 1, how many 6s were thrown in the first 600 throws of the dice? So for this, we need to look at what the result was for 600 throws. We need to see what the relative frequency was. And you just need to remember this little formula, how relative frequency is worked out. We're saying, well, whatever the result was, when we divided it by 600, we got the relative frequency of 0. And in this case, it was 34. So we need to rearrange this to find x. So in this example, we would say, well, x is going to be the result of 0.34 times 600. Now again, this is the non-calculator paper, so the way I would be thinking about this, well, 0.34 times by 100 gives me 34, and then I just need to work out 34 6 times, and that would give me an answer of 204. So down here, I'm going to write my answer of 204. For the second part of question B, we've been asked how many more 6s were recorded for these 600 throws than you would expect when a fair six-sided dice is thrown. So whenever they mention the word expectations in probability, we need to be thinking about what the probability would actually be of getting a 6 on a fair dice, and then we're multiplying it by the number of times we'd be carrying out the experiment. So in the case of a fair dice, we'd say the chance of getting a 6 is 1 in 6. If we were to run that experiment 600 times, we should expect to get 100 6s. So compare that to our experiment. We need to know how many more 6s were recorded on this dice. We need to take away the two answers. So we're taking away we got 204, take away 100. So our answer is 104.